Hey everybody, this is Paul. Welcome to lesson 54 in the Intermediate Algebra series. So in this tutorial I'll be explaining how to solve this absolute value inequality. So the first thing we want to do is we just want to go ahead and rewrite this absolute value inequality as the absolute value of some expression greater than some number. So to do that we just simply need to get rid of this plus 1 term here. So the way we do that is we just go ahead and subtract 1 from each side of the inequality. And so now we have the absolute value of 4x plus 5, and then we have plus 1 minus 1. So these two basically just cancel and reduce to a plus 0. So we don't have to write the plus 0 here. So on the left-hand side, we simply have the absolute value of 4x plus 5. And that's greater than 26 minus 1. 26 minus 1 is 25. So now we have the absolute value inequality in the right form here. We have the absolute value of some expression here. In our case, the expression is 4x plus 5, and that's greater than n. In our case, n is 25. So in lesson 50, I explained how to start the solution to this type of absolute value inequality. So when we have an absolute value inequality of this form, we start the solution by saying that the expression is less than negative n, and the expression can also be greater than positive n. So our expression is 4x plus 5. So 4x plus 5, looking at this top form up here, 4x plus 5 is less than negative n. N, once again, was our 25, so negative n is negative 25. And then over here for this one, we have the expression, once again, 4x plus 5 is greater than n. N is 25. So now we're basically just going to do a little bit of algebra and solve for x on the left-hand side of both of these. So let's go ahead and get rid of this plus 5 term here. So we're just going to subtract 5 from each side of each inequality. And a positive 5 and a negative 5 give us 0, so that just leaves us with 4x on the left-hand side here. And if you notice, this is the exact same thing for this inequality over here. So we're just going to go ahead and write 4x on this one as well. Now we have less than negative 25 minus 5. So we have a negative 25. We're taking away 5 more. Now we have negative 30. Then over here we have the greater than sign. 25 minus 5 gives us 20. And so then the next thing we want to do is we're just going to get rid of this 4 over here on both of these. And so the way we do that is we simply just divide each of these by the number 4. So 4 divided by 4 gives us 1. 1 times x simply gives us x. That's less than negative 30 divided by 4. Well, negative 30, we could just, well, let's go ahead and pull this negative out front. That doesn't change anything. And then 30 is the same thing as 2 times 15. 4 we're going to rewrite as 2 times 2, since 2 times 2 equals 4. And so now we have x is less than all of this stuff here. And then for this side, we have 4x divided by 4, which is what we had right here, and we said that was x, so we'll just go ahead and rewrite x over here. And then that's going to be greater than 20 divided by 4, which is 5. So now I'm just going to erase a little bit of this stuff up here so that I've got a little bit more room, since I'm running out of room on my whiteboard here. And so basically what we got now is we have x is less than all of this stuff right here. Well, 2 divided by 2 equals 1, so we can just cancel those out. So x is less than negative 15 over 2. And then over here we just simply have x is greater than 5. So we've got those written up there now. So now let's just go ahead and look back at this stuff for a second. So really this is our solution. X can be less than negative 15 over 2, or x can be greater than 5. So this right here would work as a solution. So there's nothing wrong with writing a solution in this form. The other way we could do it is we could write it in set builder notation. And the way we do that is we just do an opening curly brace and we name a variable. And then on the other side of this vertical bar we simply define our variable And we define it by saying that x can be any value less than negative 15 over 2. And then we just close that. And then this or, we can just simply put a u for a union. And then over here we just do set builder notation just really quick. This is going to look like that right there. So basically this means the exact same thing as this right here. It might actually be a little bit nicer to read it in this form. This is a little bit more formal, but they really just mean the same exact thing. And so if we were to look at this on a number line, basically what this solution means, let's just say that this is the number 0 here, and we'll say that negative 15 over 2 is just right there, negative 15 over 2. So that's that point right there, and then 5 can be right about there. So that will be the number 5. So basically what we're saying is we can choose any number less than negative 15 over 2. So that would be all of this stuff over here all the way to negative infinity. And we can also choose x greater than the number 5. So we can choose any of these values over here. So basically what this tells us is if we were to pick any number over here greater than 5, or if we were to pick any number less than negative 15 over 2, and then plug that value in for x and go ahead and solve all of this stuff, this would produce a solution that is greater than 26. On the other hand, if we were to choose any number in this range, it would produce a false statement here. So for instance, 0 is not part of this solution. So if we were to plug in 0 for x, 4 times 0 is 0, and then 0 plus 5 is 5, absolute value is 5 5 plus 1 is 6, and 6 is not greater than 26. So that was an example of what would happen if you were to plug in a value that's not in the solution. So on the other hand, you could plug in the value 6, which is in the solution. 6 would be over here somewhere. 6 times 4 is 24, and 24 plus 5 is 29. The absolute value of 29 is 29. 29 plus 1 is 30, and 30 is greater than 26. So that was an example of something that is in the set, and that does produce a true statement. So anything in the set will produce a true statement. Anything not in the set will produce a false statement. So anyway, I think that was the last tutorial that I was planning on doing for absolute value inequalities in the intermediate algebra playlist. If you guys want more examples on this, feel free to leave comments and let me know. And I can always make some more videos on this in some other playlist. So anyway, thanks for watching. You guys have an excellent day. And if you haven't already, don't forget to subscribe.